All right, so this language we're learning, C++, it's been said that C++ is basically C with classes. Well, what the heck is a class? A class is what we're going to get into in this example here. So you need to ask yourself why we would even need classes. Well, here is a example on where I'm trying to model something very simple and where it gets infinitely easier with classes. So here I'm trying to model basically a list of people. So I've got a list of names here that this is going to store names of, say, 5 of my friends or 5 kids or 5 people I know. And this list is going to store their ages. Now, without classes, I have to store these separately, and they're not really related in any way. In fact, the only way I can relate them here is the first name on the list is related to the first age in this list, through their index. So you can see this is going to get a little complicated. So what I've done here is I created a little for loop, go through 5 times, and it's going to ask the user for a name and an age. And of course, the names go into this list of names and the ages go in this list of ages. And then down here, this print name and age, I made a function that basically you pass in the list of names and the list of ages and then the index. So if it was the index 0, it'll print the first name in this one and the first age. And then here, if I scroll up, you can see here I'm going to see out the first person, person's name here, and then is, and their age, and then put years old. So it'll say like Bob is 12 years old. Okay? So you can see here, this is just good old-fashioned, not not uh, not using classes way of doing this. In fact, I called this file without classes. So how would we do this with classes? Well, first off, let me compile this just to show you what it's gonna do. So let's compile this thing. We'll say Clang. See what I call this, without. We'll call it app.exe. Okay, so let me move this up here. So enter name. How about Bob is 12, Joe is 13, Fred 14, Bill 15, Chuck 16. Okay, and then that function, this print name and age, will print Bob is 12, Joe is 13, Fred is 14, Bill, and so on and so forth. Make sense? So I want to implement this using classes, where it's a ton easier to combine data, like someone's name and their age, and a function to print both their name and age. Okay? So let's clear this, and let's start over. So I'm going to go here, and let's get rid of our app. Delete. Yep, gonzo. Okay, we're going to implement our class in a header file first. Okay, the header file is just the definition for a class. And then we're going to implement it in its own C++ file with the same name. So let's call this person.h. Okay, so this is a header file, so we only want to include this once in our program. So pound pragma once. Okay, whoops, I didn't do that right. Pragma, there it is. Okay, all this does is make sure that I only include this header file once. Otherwise, I'll include the definition for this class multiple times, and the compiler will freak out. All right, so to define a class, I'll type class. Okay, now you'll notice there's a few of these snippets that pop up. Okay, this one is the full-blown class. It includes the implementation and it includes the definition and the implementation. This one is just the implementation, and this one is a template, which we'll get into later. So just to show you what these look like, this one is, here's our class, it's a person. We'll get into all this stuff in a second. Here's the private data, the public part, And then here's the implementation of each of these methods right here, or functions. Okay, so let's delete all this. Let me show you what the other one looks like. Class. This is the implementation part, and it's just the definition for the class. Okay, so because I called this file person, it automatically picks up that I'm probably wanting to create a class called person, which is perfect. So we're going to delete all these comments. Okay, this is just the definition, so I can just put a semicolon after this, and there we are. So what I'm going to do here is note, so here's our class, it's called person. There's two areas. There's a private part and a public part. Okay, so anything I put right underneath this word private is going to be accessible only within this class. Okay, it's a way of compartmentalizing data. So things, I don't know, maybe a person's weight isn't public. So you could put that here, and I can use that data inside the class, but it's not publicly available. But maybe their age would be, or their name, for example. So for the sake of this, I'm going to put these here. So you can put them anywhere, it doesn't really matter the order. There's some coding practices where you either put them first or last. Just for now, we're just going to put them up here. So in our other example, we wanted to store a list of their names, or in this case, their name in this case is going to be a string, and their age in this case is going to be an int. So let me do the same here. So for once, I need to include the header for using the built-in string class that's in the standard library. So pound include string, there it is. Okay, so here I'm going to type std string, and I'm going to call this field name. Okay, this is going to be the person's name. And then I need to do their age. So int age. Okay. Now, what are these two things? This first one is called a constructor. Okay, it's the name of the class. So whatever a class is called, if you put the class name here, followed by these brackets, that is our constructor. This code, whatever in this, when we implement it, whatever in this will fire off before anything else. Before anything else in our class happens, it'll fire this off. And then in the same way, this is our destructor. So as soon as our class finishes, it's deleted, it's out of scope, whatever, this will fire right before it goes out of scope, or in our case, when our program ends, and you'll see what happens. So the last thing is, if we go back to our example, we had this function called print name and age. So let's implement that here. So let's put it here. So this is a function called print name and age. Okay, but it's going to return nothing. So we're going to make this a void function. Okay, and then just end it with a semicolon. Remember, this is just the definition for a class. There's no implementation in here. Okay, it tells us our class has a name that's a string, an age that's an int. It's got a constructor, a destructor, and one method called print name and age that returns nothing. Simple as that. Okay, now let's implement it. So I'm using, in this case, I'm using this C++ extension. So built into this extension is, you'll notice there are these three little dots underneath person. If I right click here, if I click on it, this little light bulb pops up, and the top one says create a definition of person in person.cpp. Perfect. Click that. Immediately it'll create a person.cpp file. It'll include the header, which is great, and then here's our constructor. And then what we're going to do is we're going to test and make sure this thing fires off first. So we're going to write to our console, which means we need to include IOStream. Hopefully you guys are picking this up now. Let's write, here's our constructor. So std cout constructor. Okay, that's all we're going to write. And let's go back to our definition here. We have our destructor here, so let's put that one in there. There it is. Let's do the same. Oops. All right. And then our last one, we have this print name and age function. So let's do that. Okay. So going back to our original class, what we did was we put cout, the person's name is, their age, and then put years old. So we're going to do this slightly different here. I believe it makes more sense. It's a little easier to follow. But there's a little bit different syntax that we're going to show because we're working inside a class and using fields that are part of this class. So let's start out. Let's cout. Okay, now we want to get the name of this person. Notice I said this. So we're going to use the keyword this, and then you're going to use a little dash and this symbol. It looks like an arrow. And you'll notice as soon as I do that, I have all of the public properties and fields that this class has. I have age, name, and look, there's our method. So in this case, I want name. Okay. And now I'm going to say is, and actually I'm going to come down one line. And then we're going to say this, for this class, age, years old, and then inline. Okay, makes sense? So here's our constructor. When this class is instantiated, when we create a person, this code will fire. And when we're done with it, this code will fire. And this class has a built-in function called print name and age, which will literally just print this person's name is this many years old. Okay? So if we were to implement this class similar to how we did this right here, let's go ahead and just create a new file. So we're going to call this with classes.cpp. Okay, so let's see, we're going to need IOStream, so include that. We're going to need our person class. So one thing to note here, notice I use these little greater than, less than symbols, and then I also used quotes. In the big picture, I don't believe there's really any difference internally, maybe with one slight exception. But in general, when you're using built-in header files that are part of the standard library or basically code you didn't write, you're going to use these angled symbols. When you're including files that you wrote, generally you're going to use the quotes. So just a heads up there. So we need our standard main function, so int main. Okay, good old-fashioned standard stuff. All right, now we need a list of our people. In our case, a list is an array. So let's make an array of 5 people. So people, what did I call it? Oh, I called it person. Person. In our case, we're going to have a list of persons, so just people. Actually, you know what, to make this easier, I'm going to call this kids. Okay, pretend this is a list of kids. My kids. Okay, so there it is. Okay, now because this is going on the stack, I need to tell it how many. So let's say I've got 5 kids. Okay, so let's ask the user for the names and ages of all these kids. All right, so for int I equals 0, we're going to count up to 5. I is less than 5. Okay, so I'm going to hide this so I have more room. let's go see how, enter a name. Whoops. So here I'm going to load the name that I type into the first person, or kid in this case. So I'm going to say kids, the index. Remember, we're dealing with arrays here. Now watch this. I want to put it in the name field. So I'll write dot name. So much easier. Okay. Now let's do the age. std, whoops, cout, enter an age. So same thing, kids. Whoops. There's the index dot age. Okay. So now I have so much more readable. Holy smokes. I've loaded each name into the array and each kid's age into the array through this person object. Okay. So now let's print them off. So for int I. So I can do this a couple different ways. Maybe I'll do it different just to show how you could do this. So in this case, let's just grab, let's get a reference to each person in this list. So person, I'll say kid equals kids and the index. Now, what's really happening here is I'm copying each person into this object right here. So instead of copying it, which is not efficient at all, let's just get a reference to it, which is using this ampersand. Okay? No difference, it's just a reference. Super fast and light. I'm not copying data. I'm just getting a reference to it. Okay? So we learned that like a lesson or two ago. So now I want to print the name and age of each kid. So I have a function for that built in to the person object. So I would write kid dot, check that out, it's right there, print name and age. Done. So much easier. Okay, so let's compile this thing. So note though, I have 3 files here, and really just 2 CPP files. So I need to compile this with classes and person class. Okay, so I'll leave those up just so you can see it. But let's go terminal, new terminal. Let's get rid of all these. Okay, so Clang ++. Sorry, this is gonna go in multiple lines. We'll say with classes.cpp space and then person.cpp, and then we're gonna create an app. We'll call app.exe. Yep, perfect. So now let's run it. So app.exe. Boom. Now I want to show you what just happened. Remember, in our class, we in our class, where's my person class? Here it is. In the constructor, I had it write the word constructor, and then we won't see it yet, but as soon as this program ends, you're going to see each of the objects we created is going to get destroyed, which is super cool. So you can see 1, 2, 3, 4, 5 objects were constructed. They were loaded in that array, and now we're going to enter the name for each. So Bill, maybe 12. I don't know why I'm picking these. Chuck, can't remember my own made-up kids' names and ages. Fred, 14. Here's another kid. Joe, 15. And Bob, can't forget him. Boom. So now Bill's 12, Chuck's 13, and so on and so forth. And then sure enough, you'll see, because our program ended, destructor, destructor, destructor 5 times. Okay? So I'd like you to give this a shot. See if you can make something similar. See if this makes sense. Let's just run through this one more time. So we created the definition for a person. Okay? There's no private variables. We've got a name and an age. We got a constructor, a destructor, and then one method called print name and age. That all of this stuff is, or excuse me, all these methods are implemented in our C++ file. Okay, there's a constructor, destructor, and then a print name and age function. And then in our actual program, we created a list of 5 kids, in this case, called kids. We looped through all 5, gave each one a name and an age, and then I looped through all 5 again and printed off their name and age using the built-in function that's part of every one of these person objects. So go through this, make sure it makes sense. Let me know if you got questions.